remember we talk about like physics is a very small portion. Like physics is the language of math. Sorry, math is the language of physics, right? And so we're going to set this problem up, but ultimately we're going to solve it with math. Okay, and so step one is we just got to set this up, and that's the physics. Well, let's just set it up the same way I just showed you. Well, I want to deal with, I don't know, just turn it on its side. We get M1, and we get attached to M2, the heavier one. Okay, and then on it, there's only two forces acting on it, each of them individually, right? I'm going to have gravity here. This almost forms your like elevator principle almost, right? Like this is almost how elevators work, where you'd have the elevator here, somebody standing in it, and then you'd have a counterweight to allow it to not accelerate so fast. I think that's why it's in the curriculum sort of thing, right? It's a typical elevator, right? If you didn't have a mass there, it would just, if you didn't have M1 attached to it, it would just accelerate like really, really fast, right? But the counterweight provides some reasonable amount of acceleration, which we're going to find. It might not be reasonable for this particular question, right? But that's what an engineer does for elevators, right? They design these things. What does the counterweight have to be so that it doesn't accelerate at some scary rate? It's not a roller coaster ride or something like that, right? So we're going to have Fg on this side, right? The force of gravity. And then on this side, we're going to have tension, negative T, right? And then on this side, it's the same rope, so it's going to be tension. And then we're also going to have the force of gravity this way. Okay, and so I've basically taken this question. It was a y component question. I turned it into an x1 just because. I don't know why I did that. Okay, it's just been something I got shown 10 years ago, and I've used it ever since. Right? Not everybody does questions like this, but I just find maybe I like the horizontal better than the vertical. I don't know, right? But if I look at that now, I only have forces acting purely in the x direction. Like I don't even have any components. Like there's no mg sine thetas or cos thetas. It's just negative t, positive fg, and positive t and negative fg respectively, right? And that's it. So you can do the sum of the forces for, like, you know, they're both going to move. As soon as you let go of this thing, they're both moving, right? And so there's going to be tension, a shared tension in the rope, and there's going to be a shared acceleration, both of which you don't know, which is fine. You're going to come up with two equations and have two unknowns and solve it accordingly. You can use substitution or elimination. Okay? I think these work out when you set it up like this. I think maybe this setup is more for elimination. It's just a little bit faster on the math side of things, right? But you guys can know this. That's the physics is, oh no, not quite. One more step of physics, okay? So let's set up the sum of the forces in the x direction is ma, and this can be for mass 1, okay? And we'll do the same thing over here in a minute for mass 2. We also know it's moving, so the sum of the forces in the x direction, and remember I'm dealing in the x direction here, is ma. So let's just put the forces on, right? Well, for M1, the force of gravity is pointing in the negative direction. Right, so I'm going to go negative Fg, and tension is positive, and that's equal to Ma. Okay, so I get negative M1G plus tension M1A. Okay, and you could do the math right now if you wanted to. You could go, okay, well, I'm going to isolate for T because I know what the end game is now, right? You're going to say, okay, T equals M1A plus M1G. And all I did was move this piece here to the other side. Okay, and then you can plug in some numbers. T equals, you know, M1. M1 is 8.5. 8.5A plus 8.5 times G, 9.8. Do the math. All right, I did do this one. Should be 83.3, I think. So 8.5 A plus 83.3. Okay, now this looks like a nice, it doesn't matter that it's T and A, it could be y equals mx plus b. That's all it is. All right, so just leave it. You have an equation. This is equation 1 for mass 1. Now jump over and do the same thing for M2 over here. All right, you say, okay, let's do this one. This time though, tension's negative, so we get negative tension, positive force of gravity, equal to MA. Okay, you could even, if you wanted to, you know you want to get this by itself, so just go negative T is equal to MA minus the force of gravity, and you now know, or you know what the force of gravity is. Negative tension is equal to MA minus mg. Plug in the numbers, and these are M2s, right? So negative T is equal to 17A minus 17 times 9.8. You should get 17A minus 2832.2. Does anybody have any problems? You know, I think that's physics done. I almost even think that if I wanted to get, like, you know, if I wanted to draw a physics line, I might draw it right there. The rest of this below that line's all math. You got 166. Oh, for what though, Jagger? 17 times 9.8. Oh, what did I do? Have I done something wrong? I don't know why that's so far off. Why did I do that? All right, well, let's see what happens then, you guys. You're probably right, and you are right. I don't know why I have that number down on my head. Sometimes I have like my grade 12 self making stupid mistakes. And I use those as my solutions sometimes. It's good that you guys are checking it though. I appreciate that. Okay. So let's figure out what happens then. I'm interested to see if this gives... Oh, you know what it is, guys? I don't have answers on here, so my naive grade 12 self just thought I was right. I don't even know what that was. That was so astronomically wrong. It's funny to look at. It's that wrong. 2,832. Not even close. All right. All right. So let's do this then. All right. Let's use elimination. This question's set up to use elimination, right? So I can grab this equation here and paste it over here. I know you guys can't do that, but all right. I'll try and clean this up. All right, and I'm just going to add these two together. You're going to write down what's left if I add them. Well, 1t minus 1t, that's 0t, is equal to 8.5a plus 17.5a. What is that? 17 and 3 is 20, plus another should be 25.5a. I don't know if I can do this one in my head. I need to calculate for that one. And because my answer's wrong, you guys following along? You guys get a number? What this is? It's worth going through too sometimes too, because people, they forget the negative that's sitting there, right? And they're adding things together. I don't have anything. My calculator's upstairs. 83.3 minus 166.6. Is that exactly? It's exactly half of it. I should have gotten it after all. 83.3. All right, there you go. All right, now just solve for A. You can bring this over. You can create a zero pair and add it, right? There's nothing here now because it's 0 t's. Right, so you're going to get 83.3 is equal to 25.5a. And the acceleration of the system would be 83.3 divided by 25.5. 3.27. Okay. There you go. Now, that's only half the question, but it's really not that big of a deal now, right? Because you guys have this right here at your disposal. You already have one of the equations written in terms of t. So just plug it back in there. You know t is going to equal 8.5 times 3.27. That's A, right? Plus 83.3. I wanted to write 4 ones. Jagger 3.2. Did I round wrong, Jagger? I got 3.2666. So I just rounded that to 3.27, Jagger. Oh, sorry. I'll fix that. Okay. I wanted to have 4 ones in a row, so I left it with 1 decimal place there. 111.1 newtons. Okay, that's the tension in the string. I don't know. I feel pretty good about this. Like, if we guys set it up, like I'm glad we started with the harder questions this morning. We moved to these kind of Atwood style questions. Why is different than the answer above? Did I put an answer? Oh, Elizabeth, that's because I put the answers from my naive grade 12 self. So the answers at the top of the page are going to be wrong. Okay. Ignore those. Okay. See, my sheet that I have here had no answers. Right? So when I was looking at this, I don't even know how I got 2,000. That was just ridiculous. But 2,800. But I just never paid any attention. I just looked when I was typing up my notes to work with you guys. I just was looking at the answers I had circled on my piece of paper, but they weren't even close. Okay. Something happened there. I don't know what it was. Okay, so acceleration there should be whatever it is we just solved for, 3.23, 3.27. And 111.1 newtons. Okay? That's why. Okay, sometimes I might not be nice. Oh, that's a good question too. Because let's do this question, then you guys are good for today. All right? Now, you guys be mindful. Okay, I'm going to work through this. I don't have an answer. I don't have an answer on my page. So you guys just keep me in check if I do something wrong, okay? I'll try to have an eye for it, okay? But what you can do, you can draw this Atwood machine, right? You have a smaller mass. And all I've done, right? All I've done is ask you guys to solve for something different this time. Right? It's the exact same process. I'm just going to solve for something else. Which means I have to give you something else, maybe. Okay, we're going to find out. In this case, I did. I gave you the tension. All right, so we'll draw our Atwood machine. All right, we got our ceiling, the pulley. And on the pulley, we're going to have, I don't know, M1 and M2, I think, has got to be bigger. Okay. We know M1, the smaller mass, M1, we'll say 45 kilograms. And I want to know what M2 is. Right? Okay, so let's just draw it. But we know the tension in the string this time. That's what's nice. That maybe simplifies things a little bit, right? So let's I'm just going to draw here M1. I'm going to connect it to M2 that's a little bit bigger. Right? It's still the same two forces acting on each box. We're going to have negative, well, we'll just call it tension and tension, right? And we can put the signs on after. The force of gravity here and the force of gravity here. Okay, and then remember, I just follow the conventional grid, nothing too crazy. All right, and we just do the sum of the forces for M1 and the sum of the forces for M2. We know it's going to move, right? So we just do it. Okay. I'll try to denote everything or like subscript everything with the M1. Okay. So for M1, we get negative Fg, positive tension is equal to M1A. Start filling in numbers. Or we can do one more step, M1G. And by all means, you guys don't need to do this. I do this for everybody else's sake. I remember doing this for the first time. I need to see each line. I used to. I know where it went from. But I remember the first time learning this. I'm like, I'd have a question something like this. Where did this come from? It was just FG. Oh, yeah. You know what I mean? So if you guys don't need all these lines, you don't need to write them. I'm just doing this for everybody's benefit, okay? So, well, no tension this time. That's nice. What could you find here? It almost looks like you could find something right off the bat. You guys have any ideas? Before I plug in any numbers. This is an easier question than the first one. Because I gave you something nice. Yeah, Max, we could find the acceleration right off the bat, right? Because I'll know, I know M1, I know G, and I know tension, and I know M1, so I can find A. Okay, so even if you guys wanted to, before you could divide both sides by M1, and you'd get an algebraic expression for the acceleration in this question. You don't need the arrowhead for this. Okay, you can see how this, and I brought this to your attention yesterday too. This, you're not allowed to do this. You can't cancel the M1 with the M1. We discussed this yesterday, right? Because the T is also divided by the M1, right? And you can see that here. And now you guys can plug in the numbers. Right? You're going to get the acceleration is negative 45 times 9.8 plus, what did we say the tension was? 512 newtons. All divided by 45. Now you guys make sure I get this number right. Are we okay? And we should get A to be are we okay? Did we get that? Okay, good. Grade 12 self got that one right. Okay. So let's jump over now, right? Say, okay, well, I know what the acceleration is. Let's just, for simplicity's sake, let's just follow the exact same process, just with a different box this time. Right? What's that mean? Okay, well, just tell me what the forces are acting on M2. Well, I've got negative tension and positive Fg. And that has to equal M2A. Right? So we have a negative tension plus M2G, sorry, is equal to M2A. You guys know what A is now, right? We just found it. Let's plug in some numbers. We know tension. It's negative 512, or 512, but there's a negative on it, plus, oh, there's something clever going on here. I'm going to show you guys, well, not really clever. We've already seen it, but M2 we don't know, times 9.8 is equal to 1.58 M2. All right. What now? What do we do? You guys have any ideas? Again, physics is over. I'd say physics was over right here. This is all math now. So just change your mindset. Yeah, Max. Okay, collect like terms. What's that mean? Max says collect like terms. Well, I can move this M2 over to the other side, and now I'm going to have an M2 and an M2. So let's do that first. I get negative 512 is equal to 1.58 M2 plus, no, minus, sorry. All right, so what do we get on that? Everybody guys get a number? It's funny how sometimes, like, just mentioning, like, this is just collecting like terms. That's a skill you guys have, right? You might not know that you have it, but you have it, right? It's recognizing it when things aren't in like X's and Y's or typical fashion that you've seen it in the past, right? It's just collecting like terms. The physics ends here. Right? You set up the picture, you set up your free body diagram, you set up your coordinate system, decide whether or not the object's moving, and you just go from there. You write out the sum of the forces, MA, and then once that's done, it's just filling in what you know and trying to figure out what you don't know using the math that you guys have. What you'll find is grade 11 physics. The math that you guys need for grade 11 physics comes off of your grade 10 math. That's typically how it works. And then grade 12 math will come off your grade 11 math, and so on and so forth. So by the time you hit university, you'll notice when you guys are registering for physics courses, probably even chemistry too, right? As you register for chemistry courses, they'll have a prerequisite of a math before it, right? And you'll use those skills in that previous math in that physics class. Okay, so every physics course I took in university, I took a math with it, right? That's just how it goes. Okay, did anybody get an answer there? I just didn't feel like we were doing negative 8.22. Does that seem right? Yeah, okay. All right, so now you guys get negative 8.222 M2. That was a lot of 2's. Divide both sides by. You're going to get M2 equals what? 62.3. Questions, comments, concerns? Okay, these are like, when I give you these on a test, this is got to be like a gravy train. You guys got to nail these questions, right? And I show you these because they come back up in grade 12. Like, the thing is, I don't know, because this is my first time going through this, guys. Like, it's the grade 12 university questions are very blurred with grade 11 university questions. Like, they're blurred in my mind anyway, right? And they're blurred in my mind because I had such a bad grade 11 experience, right? Like, I don't remember taking grade 11 physics. I don't remember what I learned. But my teacher did a good job at, like, and probably fits this COVID situation perfectly, right? Where, you know, some of the 4Us maybe didn't have the greatest physics experience for whatever reason, if it's online or if it was first semester of last year or like second semester of last year or whatever, right? So my physics teacher did a pretty good job at meeting us where we were because he knew the situation, right? And I think that fits the COVID situation well, right? So for the 3Us going into 4U, I think you've got a really good take on what kind of questions to expect, right? That's going to make your 4U experience that much better. And for the 4Us, I'm fine. Like, I was fine. I struggled, right? But I was okay. I struggled because my math skills were weak, right? I don't know. It'll be okay. If you guys just work through these questions, like, whatever I give you, I think there's a great mixture of stuff in here for 3U and 4U material. There wasn't a huge, like, I did not go into university and get blown out of the water, okay? And I'm speaking more to the 4U's right now, right? For the 3U's, you guys are